Hello everyone and welcome to Roadmap. I hope you are doing well. So we are continuing with the topic electric current and its effect part 3. And if you like the video, don't forget to click on thumbs up button below. You can also subscribe for more updates and you can also share the video and you can also give your suggestions in the comment section below. Now first I would suggest is go back and check the video of part 1 and part 2 because already I have covered many topics in it. And just go through it because you will be able to get better conceptual understanding and you will be able to link the concepts basically. So now we are going to cover with the effects of electric current. Already we have covered with the lighting effect and heating effect, and also we have covered with their applications. So today we are going to continue with the magnetic effect of electric current, electromagnets, uses of electromagnets, and electric bell. So introduction, I'll just give a glimpse that what we have already studied. We have already studied with the insulators, conductors, switches, short circuiting. Then we have already covered with open and closed circuit, working of an electrical appliance. So all this we have already covered in the previous videos. Coming to the magnetic effect of electric current. In 1820, Hans Christian performed an experiment that proved the magnetic effect of electric current. If you place a compass needle parallel to some current carrying conductor, you will find that the needle gets deflected. When the direction of electric current is reversed, the needle will get deflected in the opposite direction. So to understand the magnetic effect of electric current, we'll study with the diagram in more detail, but it was he who discovered this, and he concluded that a current carrying conductor has magnetic field around it. A current carrying wire acts as a magnet, and the strength of the magnetic field depends upon the magnitude of the current. The direction of the magnetic field is given by the right hand thumb rule. So let's study what exactly the right hand thumb rule is. Now imagine that you are holding a current carrying wire in your right hand with your thumb pointing along the direction of the current. The direction in which the finger coils gives the direction of the magnetic field. So from the figure you will be able to get that the direction of the magnetic field will be the right hand thumb rule. Your thumb will be showing that it is carrying current. Coming to the magnetic effect due to solenoid. What exactly solenoid is? A cylindrical coil of wire is called as solenoid. When some electric current flows through the solenoid, it behaves like a bar magnet having opposite poles at the ends. In case the coil is wound around a soft iron core, the magnetic effect increases. So the magnetism developed is not permanent. The coil only temporarily becomes a magnet. The magnetism disappears when you switch off the electric current in the wire. The magnetic field produced is very much similar to the magnetic field around a bar magnet. So this is how the solenoid looks like, and the strength of the magnetic field can be increased by some factors like increasing the numbers of turns in the solenoid, increasing the strength of electric current in the solenoid, winding the solenoid around some magnetic material. Now coming to electromagnets, what exactly electromagnets are? They are nothing but a coil wound around an iron core that acts as a magnet as long as an electric current flows through the coil. So this is called as electromagnets. And from the figure you will be able to see that there is iron rod and a battery and also the connecting copper wire. So this is how the electromagnet look like. There are some uses of electromagnets. Let's look at them one by one. Electromagnets are used in telephones, telegraphs, electric motor, electric bell, and generators. Now, powerful magnets are used in cranes. Bullet trains use the principle of electromagnetism. Audio and video tapes use the principle of magnetism. Electromagnets are used in hospitals by surgeons to remove steel splinters from eyes or wounds. Now, electromagnets are also used to lift heavy loads of iron and steel. The most important use of electromagnets is an electric motor. Now, coming to the electric bell. An electric bell is nothing but the direct application of electromagnets, and it consists of parts which are fitted on a fat wooden or plastic board. The main components are electromagnet, armature, adjustable contact screw, gong and hammer. From the figure you will be able to get. Now it has a soft iron armature which is mounted on a springy metal strip kept in front of an electromagnet. The metal strip establishes proper contact with an adjustable contact screw. And when the electromagnet pulls the armature, the circuit breaks and the current stops flowing. This keeps on repeating, producing a ringing sound as long as the switch gets pressed. So this is all about the electric bell, and in this way we are finishing with our chapter of electric current and its effect. So I hope you are enjoying the video, and thank you for watching. Stay tuned for more lessons to come.